What if I told you that you could design a complete feature-rich data logger powered by an ESP32 S3 with multiple devices such as relay, RTC, SD card, etc. just by describing your idea in few lines to an AI? In this video, I will show you how you can design this hardware all without manually planning everything in detail. Whether you are a beginner or a pro, you will see how AI is transforming hardware design, and you can use it to bring your electronics ideas to life. So, let's get started. We will use DeepSeek for designing this hardware. So, the interface of DeepSeek is very simple and it's like other AI tools only. And I will put my prompt here. I already written the prompt in my notepad so that I can avoid for increasing the length of video. So I will paste my prompt here. The prompt is very simple. I want to design a data logger using ESP32 S3 with following features. What are the features which I need in this board? It should run on 12 volt DC input. All right, so we will provide 12 volt DC input, and we need a RTC with the battery backup for timestamping, stored data in a micro SD card, read temperature using DS18B20 sensor, include two relays for controlling external devices, each with manual push button, adding a buzzer and an RGB LED for alerts, provide a USB-C port for programming and debugging, expose I2C UART, and some GPIOs for future expansion, and RS485 port. So these are the features which I need in this board. Along with this, what we need block diagram of it. All right, so we will hit OK. All right, so here's our block diagram of our project. So we have 12 volt DC input, which is converting into 5 volt and 3.3 volt. Why so? Because we know that ESP32 runs on 3.3 volt and other devices such as RTC module or relay runs on 5 volt. So for that reason, it is converting the 5 volt from 12 volt. All right, so which is great suggestion also from the DeepSeek. And further, if I see what we have extra here, so we have RTC module over I2C protocol and SD card over SPI protocol, which is correct. Then further we have our temperature sensor, relay 1, relay 2 over IO pins, and this block is referring the microcontroller. All right, do not get confused. Further we have buzzer, RGB LED, USB-C port, I2C header expansion, UART expansion, IO expansion, and RS485. All right. So basically, this will connected through UART plus RS485 transceiver. All right. So this block diagram is totally understandable, and we will follow this block diagram only for designing our schematic. All right, we can also ask for the device selection for this, and let's see what's the devices it suggests. But later on I will choose the devices my own, but you can also use the AI tools for this. Okay, so I will write. So here we got the response for the device selection. We will check it once. So the core component microcontroller ESP32 S3, which we already given in the prompt only. And for converting 12 volt into 5 volt, it is suggesting us to use MP1584. I guess it is from monolithic systems, but we will choose a different one. We will choose a buck converter IC from Texas Instrument. All right, or we yeah, this is a great suggestion. Actually, better efficiency. If you want better efficiency, so we will use this one only, TPS 5430 with this combination AP 2112K. All right, so we will use this. All right. Then for RTC DS3231, yes, it's great, and we will go with this only. For battery CR2032, yes, we are going to use this only. Then further for micro SD card, use push type, or like it is suggesting to use a level shifter as well. Then for connecting SD card is not a big deal. You can use as per your requirement, but I'm gonna use a different type of SD card slot, and I will show you in video also. Then for temperature sensor, same relay SRT. We don't need this. I'm gonna show you. We will use a Chinese relay, and that will take less space on the board. So for that reason, I'm not gonna use this one. Then buzzer, okay, buzzer also same. I will choose by my own, because we are going to make this board smaller than RGB LED WS2812B. Okay, great. And it is suggesting us to use 5050 SMD package. You can use this also, or we can use a custom one as well. Okay. Then for push button, I don't need a push button on board. We will add the push button later on. So instead of push button, we will just leave the pin there. Okay. Then USB type C. Okay. Then ITC pin header. We will use a JST connector instead of pin header. Okay. Then UART, I will just leave some test point for UART. We don't need a physical pin header for this. All right. So this device selection is almost same as per our requirement, and you can also like you can see as well that the suggestions are really great, and we are going to design the complete schematic on the basis of this input only. So here we have designed our schematic, and if you are someone who don't know how to design the schematic in KiCad or how to design the layout in KiCad, make sure to check out this playlist, how to KiCad. Basically in this playlist I have explained everything what you need in early stage for learning the software or for designing the PCB in KiCad. You notice one thing, that I have differentiated everything in blocks on the basis of their functionality, or can say on the basis of their significance. So we have power supply, programming port, microcontroller, I2C port, LDO, temperature sensor, built-in LED, and we have another sheet for RTC, SD card, and relays. I will explain one by one. So here we have power supply, which was given by the DeepSeek's response TPS 5430 DDA. So basically this is from Texas Instrument, and I have copied the same schematic from the data sheet. All right. Then further we have a programming port. So this programming port is consist of basically a female USB type C connector with a TVS diode, and we connected our decoupling capacitor as well. And you don't need to worry about anything. You can get this schematic on the GitHub repository of Ampnics. So here we have our ESP32 S3. These are the decoupling capacitor for the microcontroller. We have push button for reset and for boot, and we have some connectors for switches or for future references, such as like this. You can see here external 0 and external 1. So I keep this pin out so that if I want to use any sensor in future, then at that time I can use this. All right, then we have a addressable LED. So far we have covered these three blocks. We also have a built-in LED and a buzzer for generating the real-time feedback on the board, or we can hear some sound, or we can check the board, or we can debug something using this built-in LED. Then we have I2C and UART port. So basically this I2C port is for adding any display, or if you want to add any sensor or something on I2C protocol or I2C port, you can connect it later on. Then we have temperature sensor. So in this temperature sensor, we are using one wire temperature sensor, which is DS18B20Z. So this is the SMD version of it. So I'm using SMD version of same temperature sensor. Then we have LDO. So if you notice one thing that this time we are not using AMS 1117 because we want to make it more reliable. So for that reason, I took AP2112K. All right. So this is the functionality of this LDO is same as AMS 1117. All right. Then we have SD card and RTC. So for RTC, I'm using DS3231. So again, I'm following the data sheet only. Then we have RS485 port. So this port is responsible for basically communicating with the other nodes, or can say masters or slave. All right. Then here we are using SN 75176. Okay, it is also from Texas Instrument. Then we have SD card connector. So basically this is TF01A. It is a Chinese connector which I'm using for connecting the SD card. And along with this, we are using a TVS diode as well, so that if we can avoid any surges or any ESD effect on the SD card side. All right, and this is basically connect over SPI protocol. Then further we have relay, and we have two relay channels. So here we are using a Chinese relay. Why so? Cause I don't want to make the board too large. So for that reason, I choose this small relays. Schematic of this relay is really simple. Basically, we are having a flyback diode along with the switching transistor. That's it. So same as this, we have another relay. So this was the explanation of our schematic design. If you need custom hardware product development, feel free to reach out. Contact details are in the description. Now we will go for the reviewing of our schematic. Reviewing the schematic of the PCB is really important. Do it multiple times. Check it with at least 2-3 times, multiple iterations, so that you can avoid any minor or major problem in your design. All right. So we will take the help of AI tools, and we will check how AI can concisely review our complete schematic. And one more thing, guys, that sometimes AI review everything in detail. So I will explain you what you have to choose and what you have to ignore after reviewing the schematic. All right. So I will just export this schematic from here. What all pages close. Now schematic is already exported in the project file. All right. And then I will open DeepSeek. So we will upload our schematic here. So I will upload from here, and you will find the schematic diagram in the project folder. All right. So I will upload it here, and I will write my prompt here, review this schematic. So let's check the validated section. Power supply, it is okay. All right, that TPS 5430 supply and plus AP2112K is also correctly implemented. Input output capacitor and protection diodes are properly placed. All right, then we have ESP32 S3 core. This is also fine. Decoupling capacitors are correct. Then we have already added the TVS diode as well. RTC is also fine, and micro SD card is also fine. Level shifting is not needed. Yes, that's why I didn't included it. And CD pin is also pull up, and shielding grounding are correct. All right. So most of the sections are perfect. Okay. And termination registers are properly designed. TVS diode cells are included. Sensor and actuator. So we have already added the pull up resistor on the temperature sensor, and relay used transistor drivers Q1, Q2 with flyback diodes D10 and D11. So mostly our major blocks of our schematic is all right, like power supply, ESP, RTC, micro SD card, RS485 sensors. Okay, what are the minor issues? Let's check it out. The RGB LED, or can say addressable LED, missing decoupling capacitor. Okay, and data series resistor is also missing. All right, and what's the missing thing in the buzzer? Active buzzer is directly driven by IO7 at a base register if you are using a transistor. Okay, so I will explain you what is this basically. So if I open my schematic, I guess it is missing this thing. So basically, it is saying us that use a pull down resistor so that you can avoid that it is so that you can avoid it from floating. Okay, so we already use it. I don't think so it's a problem. And in addressable led we already used a decoupling capacitor 100 nanofarad, so this is not the problem. Okay, then IO usage, that IO 45 and 46 are input only as noted, but ensure software doesn't configure them as output. Okay, so this is for as for the firmware side, not for the hardware thing. So this is okay. This is not a problem. Test point, add ground test point near RS 485 or SD card for probing. So it is suggesting us to use a test point for near to RS485 and SD card for probing. Basically, it is for debugging. Recommended fixes. We already have a decoupling capacitor here. And let me check the series register as well. We already have a series register here on the data in pin. So you can see like after getting the response and review from the DeepSeek, you don't need to completely rely on the AI tools only. You also have to use your knowledge and use your brain as well so that you can match everything, isn't it? So this is how we got the response on the schematic review. So far we have done with the schematic review. We have checked every block which is available on our schematic. Now we will design the layout for it, and for designing the layout I will take the reference of DeepSeek again. Okay, so prompt is like, so now I will design the layout of this board with the below dimension: 0.2 mm for USB line, 0.3 mm for MCU signal to the external devices. So basically this is like whatever the devices we have connect on the board, such as temperature sensor, relays, and USB, the data plus and data minus line. 0.5 mm for 5 volt and 3.3 volt line, and 2 mm for the relay for switching the AC load. And for buck converter I prefer datasheet. I will prefer datasheet, and also I will pour the ground on the PCB for better performance. Let's check out the dimension of the tracks. So for USB and differential pair, 0.2 mm. And what is the note that we have to consider? That keep length matched. Okay, so we have to match the length, and we will try to keep it same. Okay, and 90 ohm impedance. I will let you know while designing the layout. Okay, then MCU signal 0.3 mm, short traces for I to C UART. Okay, and for 5 volt and 3.3 volt, 0.5 mm, support 1 ampere current. Yes, this is more than sufficient. For relay AC lines 2 mm, isolate from low voltage signal, at least 4 mm creepage. Okay, I will also let you know about this if you don't know. And for buck converter we are going to follow the data sheet only. Okay, along with this, if you notice one thing, that it is also telling us about the component placement, that place this component closer to TPS 5430, which is our buck converter IC, and same for the inductor as well. Okay, and use thermal pads, use vias under the TPS 5430 ground pad for heat dissipation. Yes, because when TPS 5430 comes in action, so it get heated. So for better thermal performance, what you can do, you can use vias. Okay, and for USB and ESD protection, so basically here we have to keep the length very short, and place the TVS diode near to the connector, And same thing for the termination resistor, place it near to the connector, which is true, we have to follow that. And TVS diode D7 at AB line. Okay, so we didn't use a TVS diode really here, and also it is not required for as of our design, we are not concerned about it. Okay, then for relays, keep the AC traces greater than or equal to 4 mm for. Okay, so this basically this is for, like, creepage. So I will let you know about it also. And flyback diodes D10 D11 place across the relay coils. Exactly, this is how we are going to do. And length match is important in SD card also. Okay, and shield grounding, connect shield pins to the ground. Yes guys, this is important for better performance. Okay, and for RTC, again we have to connect the battery directly, keep the length short. Okay, for grounding, signal ground plane 4 on the both layer, stitched with via with 3.3 mm diameter. Okay, so this is how we are going to follow the stuffs. And component placement is also there. Place the buck converter, LDO, ESP32 peripherals. So this is how we will do the placement actually. Okay, and apart from that, we also having about the say silk screen and documentation. So we will add a lot of graphics on the board as well. So this is our complete layout from the USB signal. Okay, here we have data plus and data minus, which is going into the TVS diode, and further it is going towards the ESP32. And here we used length matching tool. Okay, we matched the length properly so that we can avoid any performance issue later on. So you have to make sure to follow this. Okay, and if you don't know how to do it, I told you earlier in the video that follow that playlist. You will find the video how to use differential pair and how to match the length of tracks. Okay, and same thing I followed here as well in the RS485 section and for here as well. Okay, so it is important to match the length for USB, for SD card, and for RS485 line. And later on we have 0.3 mm for the signals, which is connecting to the devices such as temperature sensor, addressable LED, or buzzer, or switches. Okay, and for buck converter we followed the data sheet. Okay, and here we have directly connected the VWAT in near to the IC, or directly connected to the pin of IC. Okay, which is RTS3231. And for relay, we did the creepage as well, that we didn't code any, or we didn't design any DC signal here, because it will handle AC current, so it is necessary to keep the DC signal away from it. All right, and here we added the diodes as well. We'll turn on the 3D viewer, you will get a better idea of our board, basically how it is looking like in 3D view. And guys, I will also suggest you to always use 3D viewer so that you can judge the height and everything, whatever you used on your board, you have an idea that how will your PCB look like. So pretty much we tried to follow the suggestion of DeepSeek. We kept the relay on the left side, and we kept the SD card and ESP SD card and programming port on the right side. And this is basically creepage area, that the AC signal and DC signal, in between of them we have a gap, so that we can avoid any interference or you know signal integrity issues. And we have RTC here, buck converter here, ESP32 here, and the other components such as switches and RS485 is here, and the termination resistor is here. So This is how we designed the board, and if I flip this board, you can see from back side it look like this. Okay, so if you notice one thing in my all the design board, that I use a lot of silk screen graphics. Why so? Cause it improves the aesthetic of the PCB. So for that reason I use a lot of graphics on the PCB. Okay, and guys, let me know on a scale of 10, rate the PCB in comment section and tell me if you want to design it, how will you design, or do you like this design, or you want to change something in this. Make sure to comment it below so that I can get an idea what do you think about the designing. Okay, so this was the video on data logger using KiCad and DeepSeek. Found it helpful? Make sure to hit the like button and subscribe the channel for more technical content.